Hello. I thought I would do another puzzle. And I guess I really do mean another puzzle. Just a few minutes ago, I did It's a Numbers Game by Will Power, and I made a recording of it. So maybe that'll be the video right before this one. But I have some time for another, and when I was picking out It's a Numbers Game, I saw that the Dutch Flatmates Diagonal Sum puzzle just came out. Dutch Flatmates is this weekly series by Flinty, and I've done a number of them. I guess I didn't do Numbered Rooms. I missed that one, but I skipped over making the Dutch Flatmates puzzle because I had done so many Dutch Flatmates videos. Anyway, I just wrapped up It's a Numbers Game. Thought I'd make another, and you know what? This is when we'll do Dutch Flatmates. So it'll be another Dutch Flatmates video. I'm sure by now I have 3, maybe as many as 5. There's one who I've recorded the solution to. Oh geez, I forget which one it was. It might be Region Line Sums, but that video turned out to be 1 hour and 40 minutes, and I just haven't posted it yet because I haven't brought myself to watch the whole thing and make sure that there are no glaring errors or anything like that. But this is Dutch Flatmates Diagonal Sums. It is a puzzle that is by Flinty. It is 9.1 hours old, and there have only been 45 solvers. So what I'll do is I'll try to make myself the 46th solver. But these Dutch Flatmates puzzles have been a lot of fun, so I am excited to try this one out. Let's see how it works, because these are some big numbers. I wonder what the rules are. Normal Sudoku rules apply. 5s live in Dutch flats. All 5s in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. Okay. Diagonal X sums. Clues outside of the grid are the sum of the first X cells in the corresponding diagonal, where the X is the digit in the cell nearest to the clue. Digits may repeat, and where the X exceeds the number of cells in the direction, the sum bounces off the edge at a 90-degree angle and continues. So I've never done one of these diagonal X sums before, especially not with the bouncing. This is going to be fun. I have a lot of experience with the Dutch Flatmate rule, but I have no experience with a bouncing diagonal X sum. None at all. This will be my first puzzle. But with that, maybe I should play through the rules on the board. It's a 9x9 puzzle. We're going to need to place a 1 through a 9 in every row, column, and region. There are these Dutch 5s. 5s live in Dutch flats. Anytime we have a 5 in the grid somewhere, we're either going to need to place a 9 below it or a 1 above it. And we can even have both, but that's not a requirement. So that's the Dutch Flatmate rule. And the last thing has to do with these diagonal X sums. When we have a diagonal like this, like 58, then there's going to be a number here, okay? Say that number was 6. What that tells us is that the 6 cells along this diagonal with bouncing are all going to sum to be 58. And I have no experience with this rule. Did I do it correctly? Is this 6? This is 6. It looks like 7 to me for whatever reason, because I see 4 cells and 3 cells, but actually it's just 6. 1, 2, 3, 4, 5, 6. But those are going to need to sum to be 58 in the end. So that's going to be interesting. We even have these double diagonals, like this 10. Is there anything about uniqueness in the rule? Digits may repeat. Yeah, they're non-unique digits. This is going to be challenging. This is going to be challenging. But where to start? I think this is a 2-star puzzle. Yeah, this is going to be a challenging one. We'll see how long it takes. I'm not quite sure. I did not know what I was getting myself into when I clicked on the link. Excuse me. But what am I getting myself into? let's see. Well, I may cough again. I know some things. The maximum number that could possibly go in this cell is 9. If this was a 9, we would have something that looks like this. If this cell here was a 9, then all of these cells would need to sum up to 49. But that's the maximum. I could even like draw in the maximum arrows and think about them. How do I want to approach this? Well, I should think about what some minimum sums are and some maximum sums. If we took the maximum sum of 3 numbers, take the numbers 1 through 9, choose 3 and sum them up. What's the maximum sum you could possibly get? I would get 7 plus 8 plus 9 is 24. So if I was to do that 3 times, 24 times 3 is only 72, which is less than this. I have a feeling it's going to be difficult to make 76 here, just because of how big this number is and how few additions we are allowed to use. Let me sort of explain. Oh man, and then these are on the same diagonal. This 76, I'm going to have difficulty drawing the diagonal. It's going to look something like this. This 76 sees this 58 here. That's interesting and cool. This 58 is certainly going to need to bounce because it's going to need to bounce. And I have a strong feeling that this 76 is going to need to bounce as well. Let me think about putting in the maximum numbers possible for the 76 and just see what happens. So say this was a 9. And then say in these cells we hit 7 and 8. Or excuse me, 8 and 9. See, this is the maximum we could have along the diagonal. And then again here I could have a 9. And then again here I could have a 9 and an 8. And then here I could have the numbers 7, 8, and 9. This is what I consider to be the maximum possible sum. I mean, I don't know why I said I consider it to be. I think this is the maximum. We're looking at the shape of this diagonal here with the bounce. We're looking at all 9 numbers, and this is the largest possible sum we could get out of all of them. What would that sum be? Well, 8 and 9 add to 17. So together with 9, we would have 26, then 35. Then we'd add another 17. We'd get to 52. And then here we would add 24, and we would get to 76. This is the way it needs to be. There needs to be a 9 here, there needs to be a 9 here, and there needs to be 8 and 9, there needs to be 8 and 9, and then there needs to be 7, 8, and 9. It needs to be like this. But we're not allowed to put a 9 here. Why is that? Because if the 9 goes here, then because of this bouncing, we're going to get boop, boop, boop. We're going to have 9 numbers in the sum, and those 9 numbers are going to add up to 76. So you're not allowed to be a 9. Are you allowed to be an 8? Well, if you were an 8, we would have 76. We would have the full sum would be 76, except we would subtract this 9 here. And when we subtract 9 from 76, we get 67. That's just a little too big. You're not allowed to be an 8 either. You need to be a 7, is what you need to be. And now, neither of you are allowed to be 7. The first 7 numbers, these 7, need to add to 58. We could just think about what is the difference in between 76 and 58. That difference is going to be the sum of these 2 numbers. That difference is 18. 76 minus 58 is 18. These 2 numbers need to sum to 18. That means you need to be a 9, and you need to be an 8. And now I think it all works out. I think when we add up the 7 numbers here, these 7 numbers, excuse me, we're going to get to 58. And when we add up these 9 numbers, we're going to get to 76. This is going to be a difficult puzzle to explain as I go because I have difficulty highlighting the diagonals. But yeah, no matter. So this is great. Let's do some thinking. I have a feeling that we have to start with the X sums rule. We're only really given two novel rules. The first rule, non-novel, is just the normal Sudoku rules apply. The second rule has to do with these Dutch flatmates, and the third rule has to do with these diagonal X sums. And I've started by playing with this 76 and this 58, the X sum rule. At some point, I'm going to need to start thinking about the Dutch flatmate rule. With the Dutch flatmates, anytime we have a 5, we're either going to need a 9 below the 5 or a 1 above the 5. I don't really see a great way to apply that here just yet. But no matter, I think we have squeezed all of the information we can out of this 58 and this 76. Are there other numbers that we can squeeze information out of? I'm not sure. Excuse me, I'm like cough burping or something. One thing is that this needs to be, this cell here can only be an 8 or a 9. This cell will be its complement. So if this is an 8, this is a 9. And then this is also the complement of this because these two need to be unique. So these two cells are definitely the same. And these two cells are definitely the same. But that's not necessarily what I was going for. What I was going for is that one of these two cells needs to be a 9. And the thing about a 9 in this row is that the 5 is going to need to appear directly above it. Why is this? Let's just say we have a 9 in this row. Now I need to place a 5 somewhere in this row. That 5 can't have a 1 above it. But by the Dutch flatmate rule, it's going to need a flatmate. It's going to need a 9 below it. So as soon as we know where the 9 goes in this row, we know where the 5 goes in this row. We know in this row that the 9 is either going to appear here or here. That means the 5 is either going to appear here or here. But the thing that's interesting about that is that we need to add to, there's going to be a 5 here, it would become the x of this 10, or a 5 here, it would become the x of this 10. That 5 definitely needs to be one of these X cells. And I don't know if it's possible for this to be a 5. This one here. Say this was a 5 and we needed to add to 10. What's the minimum possible numbers that could go in here? They'd be 1 and 2. We could have like a 1 and a 2. Now these three numbers would add to 8, but we would need there to be 5 numbers that add to 10. These would both need to be a 1, and that's not allowed. So you can't be a 5. You need to be a 5. You need to be a 5, and you need to be a 9. Now you need to be an 8, and you need to be an 8, and you need to be a 9. And now these 5 numbers are going to sum to 10. Again, we're going to need to use a 1 and 2 here, and then a 1 and a 1 here. That's what's going to need to happen. You need to be the numbers 1 and 2. I don't know, that I kind of jumped through that pretty quickly, but it's the only way to add to 10 with 5 numbers. We're going to need 3 1s, a 2, and a 5. And it doesn't work over here. Anyway, you are our 5. Now we know where these 1s and 2s go. Great. I wonder if we can apply the Dutch flatmate rule more, or whether or not we should stick with the X sums rule. Where does a 5 have to go in this region? We can narrow it down, I think, pretty quickly. So you can't be a 5, for example, because you would either need a 1 above you, that would contradict with this one, or a 9 below you, which would contradict with this 9. So you can't be a 5. You can. You would have a 1 above you. But you two cannot. Actually, you 3 cannot, for the following reason. With a 5, you either need a 1 on top or a 9 below. You can have both, but you don't need both. But what you can't have is a 9 on top. I can't place a 5 here with a 9 on top of it, because that would mean that we don't have a 1 on top of it. We would need a 9 below it, and then these two 9s would contradict. For the same reason, you can't have a 5 with a 1 below it. You cannot be a 5, you cannot be a 5, you cannot be a 5. Can you be a 5? If you're a 5, you would need a 9 below you. That would cause a contradiction, or a 1 above you, and that would cause a contradiction. Same is true with you. You'd need a 1 above you, we'd have a contradiction, or a 9 below you. And just like that, I think we have narrowed down our 5 in this region here to only one cell. It's this cell. Cool. Cool, cool. Cool, cool. But I don't know if we can apply that in other places. I guess wherever the 5 goes in this region, we're going to need to place a 1 above that 5. It's not super insightful, but we can't have 9s in these columns, right? Which means it's not really possible to place a 5 with a 9 below it anywhere in this region. Because of the 9 here, we would need a 1 above it. Anyway, we can keep moving. But how? I have a feeling we're 50 minutes in the puzzle. I have a feeling that this 1 is going to become restrictive with this 49 in some way. Similarly, I think this 26 and this 9 are going to become a bit restrictive. So, for example, the maximum possible number for this is 7. And maximum, this is 7. I'm trying to think about whether or not it's possible to put a low number in this x by this 26. A low number might look something like 3. Okay, well then these 3 numbers would need to add to 26. This one's at maximum 7, which means the maximum sum of this plus this is 10, which means the minimum value for this cell would be 16, which wouldn't be allowed. You're no longer allowed to be a 3, which means you need to be at least 4. And if you're at least 4, then you definitely contain the 9. This diagonal sum definitely hits the 9 here. And I feel like that's going to cause some complications. I don't know whether or not this needs to be a 4. This needs to be at minimum 4. But if this was a 4 and this was a 9, the outside, if this was a 4, then these 4 cells would need to sum to 26. These sum to 13, which means these would need to sum to 13. I don't know if this is the road I want to continue to go down or whether I should erase this and look someplace else, but for these to add to 13, neither of them are allowed to contain a 9, which means we could have 8 and 5. This would put an 8 here and a 5 here. Or we could have 7 and 6. And I think either of those possibilities are possibilities, which I think means this can be a 4. So maybe we don't think about that. Still, maybe the next thing to do is to think about this one. Yeah, I don't know. Let's think about this one. You need to be a pretty big number, I think, because you sum to 49. 49 is 7 squared. That's not going to be helpful here, but that's a fact about 49. What is going to be helpful here? Well, you definitely can't be a small number. You can't be 3, just because of the same logic we applied with the 26, sort of. I don't think you can be a 4. If you're a 4, then you 4 numbers need to sum to 49. You sum to 5. You guys would need to sum to, you guys would need to sum to 44. That's just a little too big. It's actually a lot too big, but you're not allowed to be a 4. Can you be a 5? You actually just can't be a 5 at all. This really restricts this cell because you also can't be a 7 or a 9. You can only be a 6 or an 8, and I wonder if only one of those is a possibility. I bet you're an 8. I bet you're an 8, but I want to prove it to myself. If you're a 6, then these 6 numbers need to sum to 49. We know that this one's a 6, this one's a 1. Those add to 7, which means that the remaining 4 numbers need to sum to 42. And 42 is more than 4 times 10. And there's 4 cells. So you can't be a 6, actually. You need to be an 8. You need to be an 8. And now it is these 8 cells need to sum to 49. Gotta keep a lot of numbers in your head. All right, you 2 sum to 9, which means the remaining 6 numbers need to sum to 40. You're going to have a high average. I bet if we place the maximum, what we're going to see is some problems. I bet. Because these cells are not allowed to contain a 8 or a 9. The maximum numbers that could go here are the numbers 7, 6, and 5. In fact, there's only one way of configuring those numbers, it looks like. 7 plus 6 plus 5 is 18, right? 18 plus 9 is 27. And now the remaining 3 numbers here would need to add to 22. The maximum that this could be is 7, and then how are we going to add to 15 here if we're not allowed to use... I think there's only one way of doing it. I just think that there's only one way of doing it. I think this is going to be an 8. I think this needs to be a 6. That means this needs to be a 7, and this needs to be a 5. I mean, you know, we could add there's really at least 1 degree of freedom in this, right? The maximum that you could possibly be is 7. We should just fill in all of the maximum set and then just see what it adds to. I think that's the easiest way of proving it to ourselves. Neither of you are allowed to be a 9, but you could be an 8. And then you're not allowed to be an 8 or a 9, but I suppose you could be a 7. So now these numbers add to 15. These numbers add to 18. 33. And these add to 16. 49. Yeah, there's only one way of adding to 49, and it's to use this number set. This has been a really fun puzzle. I really like the Dutch Flatmate series by Flinty. I was sorry to not play the puzzle in the last video I made. I saw Dutch Flatmates. I exclaimed, oh man, Dutch Flatmates is out in the video. And then I went on and did something else. But I'm glad that I got some time today to come back to Dutch Flatmates. And this has been a fun one. Cool, so now we've exhausted this diagonal x sum. We should do some more diagonal x sums, but maybe first we should think about the Dutch Flatmate rule. I need to place a 5 in this region someplace. Because of this 5 here and this 5 here, what we would need is the 5 to either appear in one of these cells. 5 must appear in one of these cells. This one here can't be a 5. If you're a 5, you can't have a 9 below you. You'd need a 1 above you. That would cause a problem. If you're a 5, actually, you're going to already have your flatmate. And if you're a 5, then you need to be a 9. So maybe that wasn't the most helpful one to start with. Is there a better one to start with? One of you two needs to be a 5? Because, see, there's 5s in these rows. If this was a 5, this would need to be a 9. That would cause a contradiction. In fact, you need to be a 5. And now you're not allowed to have a 9 below you for 2 reasons. 3 reasons. 2 reasons? Why are you not allowed to have a 9 below you? Well, there's a 9 in the row, there's a 9 in the column, and there's a 9 in the region. So a whole bunch of reasons why there can't be a 9 below this 5. There needs to be a 1 above this 5. And now there needs to be a 2 over here, a 1 over here, and everything is gravy or groovy, depending on how you exclaim that things are going okay. So, used a whole bunch of the Dutch flatmates. Can we use more of the Dutch flatmates? I'm going to still need to place 5s. I need to place a 5 in this region someplace. That 5 can only go in one of these cells here. One of you must be a 5. You're allowed to be a 5. You would have a Dutch neighbor below you. But you're not allowed to be a 5. And neither are you. If you were a 5, you would need a 1 above you. There's already a 1 in the row. If you're a 5, you would need a 9 below you. There's already a 9 in the region. You are definitely my 5. And you have a Dutch friend, or maybe the 5 is Dutch, one of you is Dutch. Now we need a 5 up here. If this was a 5, this could be a 9. If this is a 5, there's a 1 above you. Oh, I guess you're not allowed to be a 5 at all, and I think I knew that already. You need to be a 5, you need a Dutch friend, and your Dutch friend is going to be a 9. Cool, so we've placed a whole bunch of 5s. All of the 5s that we've placed have their Dutch flatmate neighbor. Yep. I don't know if it's possible to place more 5s, but we could try. So there needs to be a 5 in this column somewhere. Can't go in either of these regions. So there needs to be a 5 in one of these cells. But what's the problem with that? Is there a problem with that? Well, there's already a 9 in this column, which means wherever the 5 appears, it needs to have a 1 above it. But this 5, if you placed a 1 above it, it would intersect with this 1 here. You're actually not allowed to be a 5, but either of you could be. And I guess what that also means is that we know where the 1 goes. The 1 is going to appear here or here. And now, there's definitely a 1 in this column, and there's definitely a 1 in this column. You need to be a 1. I could keep moving. There needs to be a 5. There needs to be a 5 in this column here. One of you must be a 5. And because of the fact that there's a 1 in the column, this 5 needs a 9 below it. So one of you are a 5. You need a 9 below you. That means that you're not allowed to be a 5. And then this is certainly, there certainly needs to be a 9 in here somewhere. Last thing's last. Last thing is last. I suppose there needs to be a 5 in this column. It needs to go somewhere here. So one of you must be a 5. I don't think it's possible for any of you to have a 9 below you. Just because of this 9, because of the Dutch flatmate rule, you're going to need a 1 that is above you. So either this is a 1, or this is a 1, or this is a 1. Well, I guess we know that there's going to be a 1 in this region, and it can't appear in this row, or this column. You, my friend, need to be a 1. And now the 5 that's down here needs a 1 above it. There's already a 1 in the column, which means you need to be a 5. Now, if you need to be a 5, then you need to be a 5, and you need to be a 9. And now you need to be a 5, and you need to be a 1. And I believe at this point we have placed all of the Dutch 5s and their Dutch neighbors, but there may still be locations where we could insert a 1 or a 9 if we wanted to. Let's try to figure out where those would be. We need a 9 in this region someplace. This is the only square that can accommodate a 9. And now, at this point, we need a 9 in this. That needs to go up here. So we've completed all of the 5s. We know where all the 5s go. We know where all the 9s go. Can we figure out where all of the 1s go? And I'm not sure that we can. One of these needs to be a 1. And in this area, one of these needs to be a 1. Maybe I should mark that to myself. I don't see why not. So we've almost placed all of the 1s. We have placed all of the 5s and all of the 9s. Diagonal X sums, Dutch flatmates. I love this puzzle series. I hope Flinty continues it as long as possible. I've played through a lot of them. All right, what to do now? What to do now is to figure out what to do with this 26. Because, I don't know, I drew it as though it's going to bend like that. We have a lot of numbers filled in along the bounce. I wonder what can go here. Before we were looking at 3 and we were looking at 4, and maybe we said 4 was possible, I'm not sure, but I don't think 4 is possible now. Because these add to, these 3 numbers here add to 15. So, these numbers here add to 15. If a 4 was here, then these 4 numbers would add to 19, and that would just be a little bit too low. But you're also not allowed to be a 5, as it happens. So the minimum that you could be is a 6. You can be a 6. And you could be a 7 or an 8, I think. But you can't be a 9, 6, 7, or 8. I wonder how things get complicated as this number moves. So say that you're a 6. Then we would need these 6 numbers to add to 26. If you're a 6, 6 plus 15 is 21. And these would need to add to 5. We would get 2 and 3. And that's allowed. You're allowed to be a 6. Are you allowed to be a 7? If you're a 7, then these numbers add to be 24. Excuse me, that's not right at all. 22 is what you are summed to, and this is a 7. This is a 7, then these 4 numbers are going to add to be 22. That would mean these 4 numbers would need to add to 4. And I think the only way of doing that is to make this a 1 and this a 1 and a 2. That would create all sorts of problems because we already have a 1 in this region and this region. You're not allowed to be a 7. Consequently, you're not allowed to be an 8. You must be a 6. And now I just filled it in, but you guys need to be the numbers 2 and 3. And I believe if you're the numbers 2 and 3, then this bouncy diagonal is going to add to 26, and everything is groovy or gravy. We need to add to 15 here. That sounds difficult. Why does that sound difficult? It sounds difficult because there's a 5 here. Obviously, we couldn't put a 1 in the x of the x cell. There's already a 1 in the region, but the sum of the first 1 number in a set that starts with 1 is 1. So you can't be 1. You also can't be 2. The sum of the first 2 numbers would be 7. Could you be 3? Then this would need to be a 7. That seems like it's allowed. 3 plus 5 plus 7 is 15. How about 4? If you were a 4, then you 2 would sum to 9, and you would need to be you 2 would need to sum to 6. You would need to sum to 6, but you couldn't use the number 1. You would need to be the numbers 2 and 4. And that's allowed. But you're not allowed to be a 5, and I think that you're also not allowed to be a 6, because I think it's going to become very difficult to sum to 15 with 6 numbers. With some of these uniqueness things. I think you're allowed to be a 3, and I think you're allowed to be a 4. But I think that's what we have, 3 and 4. If that's all true, then I think we've sort of exhausted all of the rules that we've been given. A thing that I sometimes forget to do, that I you know, I get lost in one rule and maybe that's not the rule to apply. Maybe to start the puzzle you need to use some other rule. But this is a situation in which we're only given two rules, the diagonal sums rule and the Dutch 5 rule, and at least for now I think we've exhausted both. What that would mean is that we can only apply this other rule, the one I called not novel. It's the classic Sudoku rule. We need to start applying that, and there are already ways to do it. So where would an 8 need to go in this puzzle? Well, in this region, an 8 needs to go here. This is just some classic Sudoku thinking. And now in this region, an 8 needs to go here. And what else? In this region, we need an 8. We know it can't go in this column, or this needs to go here, because you're not allowed to be an 8. You're only allowed to be a 3 or a 4. And now you need to be an 8. Now we used all of the 8s we have, so we've exhausted all of the 8s. Can we move on to 7s? There needs to be a 7 in this region. That 7 needs to go here. Let's see. More? Can we do more? Can we do more? There needs to be a 7 in this region. That 7 is going to be forced to be in one of these two cells. But what that means is that in this column we know where the 7 goes, and it goes in this region. In this column we know where the 7 goes, it goes in this region. One of you two must be a 7. But I don't know if that's particularly profound. How about 6s? One of you two must be a 6. We've done 5s. Have we tried 2s? We don't have enough 2s really to make any progress. All right, well, I'm hoping that that little bit of a classic Sudoku play is enough to get through this diagonal x sum at the bottom, because we need to start applying our rules down here. Anyway, if this was a 3, these two numbers would add to 8. And then we would need a 7 here. That's not allowed because of the 7. You're no longer allowed to be a 3. You need to be a 4. Now you two need to add to 6, but we can't use 1. You two need to add to 6, but we can't use 1. Usually in this situation I say something like, well, there's only 2 ways to add to 6. 1 and 5 and 2 and 4. As it happens, there's a third way of adding to 6. In this setting, it's 3 and 3. Okay. Well, we need to add to 6. You two could both be 3. That would be allowed. We can't use a 1, but I think you could be 2 and 4. I think 2 and 4 is also allowed. I think this is what's allowed along this diagonal here. Interesting. Now I need a 2 in this region. That 2 can't go here. It's got to go here. Now you can't be a 2. That means you can't be a 4, by the way. You can't be a 2. You can't be a 4. Still narrowing it in. Can we do something with something, or do we just go back to the classic Sudoku rules again now that we know that there's a 4 here? What am I missing here? Well, let me erase these. I'm missing a 1, we know that, and I'm missing a 6. I'm also missing a derp 3. 3 is the other one I'm missing. You're not allowed to be a 1, and you're not allowed to be a 6. How about you? I guess I should be able to fill in you, shouldn't I? You need to be a 4. Now what about you guys? You need to be the numbers 3 and 6. 6 needs to go here. 3 needs to go here. Now in this column we're missing some numbers. We're missing the numbers 2 and having difficulty finding the other one, 4. 2 and 4 is what goes in here. And in this column we're missing some numbers. What are we missing? We're missing the numbers 3 and 6. This is all still allowed. In this row, we're missing some numbers. What numbers are we missing? We're missing the numbers 3, and we're missing the numbers 4, the number 4. In this row, we're missing some numbers. We're missing the numbers 2, and we're missing the number 4. Yeah, all allowed, all allowed. Guess what that means is that you can only be the numbers. You could only be 2, 3, or 4, but you're not allowed to be a 4. You need to be a 2 or a 3. That means that there needs to be a 4 in this column. So we need to place a 4 in this region someplace. That 4 is either going to appear here or here, just like a 4 is going to appear here or here. Missing a 2, I'm missing a 6. You can be the numbers 2 and 6. That's all allowed. Hold on a second. I'm also missing the number 3 in this row. There needs to be a 6 up here. This is the part of the puzzle where things slow down because we enter Classic Sudoku-ville. And in Classic Sudoku-ville, you just have to... I don't know what you just have to do, but it becomes more about finding the number that you didn't see previously than it does about applying some rule that you've had in your back pocket this whole time. In fact, I'm almost sure that somehow my, filling in notation on the board has made things more difficult for myself than I needed them. Has made it more difficult than it should be. But if I erased all these, which I don't think I'm going to do, then the answer would pop out pretty fast. But yeah. I want this... Is it possible for this to be a 4 and a 2? Because there's some 4 stuff up here, and there's a 2 and a 4 down here. I just wonder, like if this was a 4, we know that this would need to be a 2 because of the x sum. But then the problem is that a 4 can't go, a 4 would need to go here. This would then need to be a 2 and a 4. That seems to work out. Interesting. "42 minutes in." We'll see how long I stay in this Classic Sudoku hole. The 8s are filled in. The 5s are filled in. The 7s are not filled in as well. There needs to be a 7 in this region. Can't go here. Can't go here. But it can't go here. That 7 needs to go here. That means this needs to be a 4. That means this needs to be a 2, and this needs to be a 4. Has that cleared up anything for us? You need to be a 3, and you need to be a 7. And now you need to be a 2. I'm missing some things. In this row, I'm missing... Well, in this whole row, I'm missing a 3, but that 3 can't go in either of these two. You need to be a 3. Now you need to be a 6. Now you need to be a 6. Now you are not allowed to be a 6. Still, we don't know what's going on with this X. Still kind of difficult to place it down there. It has started lightning storming outside. That's some interesting thing. There needs to be a 4 and there needs to be a 6 in this row. And I think that either will do the job for us in either cell. You're not allowed to be a 3. I could take that out. You're not allowed to be a 2. I could take that out. In this column, forget this column. You can only be a 2 or a 3. One, 2. There needs to be a 3 up here. There could be a 4 or a 6 up there. I guess I should continue just using the numbers. Maybe. I'm not so sure. 2, 3. Where are the rows and columns that are almost filled up? This one, in this column, I need a 2, 4, and a 6. That means this can be a 2, a 4, or a 6. But that's not so helpful. In this row, I'm missing a 7. 7 can't go here, and it can't go here, and it can't go here. It needs to go here. You are our missing 7, which means you are our missing 1. Now this is going to be a 3 and a 6 in the end, which means you need to be a 1. And I believe at this point we have filled in all of the 1s. Have we filled in all of the 7s? We haven't. There's this missing mystery 7. You are missing mystery 7. And I think at this point, we're in a pretty good place to wrap this all up. He says, what am I missing in this region? I'm missing a 2. That 2 can't go up here. That 2 needs to go here. I'm also missing a 3 and a 4, but you can't be a 4. You need to be a 3, and now you need to be a 4 so that you can be a 2, so that you can be a 6, and now you're a 3, and you're a 3, and you're a 4, and you're a 2. I'll move to the keyboard, and I'll move my mouse out of the way. You need to be a 3, you need to be a 3, you need to be a 6. If I can see the keyboard that I'm trying to use, you need to be a 6, you need to be a 4. Now you need to be a 6. Now in this column, we're only missing one number, and what is the number that we are missing? 1, 2, 3, we are missing 4. You're a 4. And now in these rows, we're missing some numbers. We're missing the number 2, and we're also missing the number 3. 3 is the number that we are missing. We have solved the puzzle. We are the 49th solver. Is that? Huh. I wonder how many people have solved it since, I guess maybe when we started there were 45 solvers. Is that what I said? So 4 people have solved it, including myself in this interim. In 9.9 hours, I was one of the people that solved it in the first 10 hours of it being out. That was a lot of fun. I really like this Dutch Flatmate series by Flinty. I encourage anyone who is interested in puzzling to go to the Dutch Logic Masters website or Google it or look through Cracking the Cryptic. I'm sure that they have them posted somewhere. But thank you, Flinty, for the puzzle. I hope to do more of the Dutch Flatmate series too, and thank you for watching me do the puzzle. Viewer, hope to see you again soon.